I'd like to thank everybody for joining us this morning for our fifth port committee meeting. Let's start by going on the table. Steve, if you'd be kind enough to start the honors.
Steve Rebuffo, Deputy Port Director.
Todd Coles, Ports Engineer.
Port Director, Bill Sheffield.
Mike Gutierrez, Assembly.
Ernie Hall, Assembly.
Patrick Flynn, Assembly.
Debbie Osiander, Assembly, and I've asked Geotech Advisory Commission member Mr. Shearer, who's the chair, to come there by code, our official advisor on anything relating to geotech. And since some things on the agenda today are in that era, and they have had some correspondence on this topic in the past, I really am thankful that they're able to make it today. So thank you, Mr. Shearer. And I've forgotten, unfortunately, already the names of the other two guys.
I'm David Cole on the Commission, Geotech Commission. Keith Mobley, Geotechnical Advisory Commission.
Thank you.
I'm Mike Spitz with ICRC. We're part of the presentation team today.
Right. And did the Marriott folks make it online yet? Doesn't sound like it. Okay, we'll keep an ear out for them. First item I wanted to, well, actually, before I start, is there any changes to the agenda we need to make today, or is everything? Morning.
This is Marriott in Washington, D.C. calling.
Good morning. We're just getting started. What was your name, ma'am?
I'm sorry, you're coming in and out here.
I apologize. What was your name, ma'am?
My name is Susan Lee. I'm the co-chair on the project, and I've got
Ray Leon from the Office of Acquisition.
and
Gustavo Vecino, Civil Engineer.
Great. Welcome. We're glad you could join us. We're going to start with a quick update on, I don't know if you've got a copy of the agenda forwarded to you from anybody, but we're going to start with a quick discussion of the navigation concerns that TOTE expressed regarding their move to the North Extension. Then we'll go over the inspections on last year's work, and then we'll move into the discussion of sheet melt pile technology before finishing up with some finance data. Anything else? Do you have any questions about that?
No.
Great. Okay. Well, with that, Governor, you want to update us on how we're doing on getting TOTE's concerns resolved with the North Extension?
Yeah, I'm going to have Todd Coles talk about that.
All right. I've provided you two handouts. Actually, one of these you've seen already. It's the phasing plan dated June 22nd, 2010. That's our kind of master scenario showing the phasing, and we've talked about it before. The other 11 by 17 plan then is labeled Alt 2 North End phasing and is dated August 13th, 2010. What I want to point out here is if you look at the 622 phasing plan, you can see the footprint of the North Extension fill area as it exists today. You can see the dimensions that are shown there for the wet barge berth, though it's not, well, it's labeled in yellow, they're wet barge berths, 400 feet. Then TOTE's temporary berth, 1,000 feet. Then Horizon's temporary berth, 800 feet. What we've done to work with TOTE and address their concerns primarily were ones of having sufficient buffer at the minus 35 dredge depth for their approach to the berth. So if you look now over to the Alt 2 phasing plan, you can see how we've adjusted these dimensions to hopefully accommodate that need. And you can see now that the wet barge berth dimension is proposed to be 700 feet, TOTE's berth increasing to 1,100, and Horizon's berth ultimately increasing to 1,050. That provides enough room there at the North Extension to give TOTE the 400-foot buffer to the minus 35 dredge depth, and you can see that handwritten dimension 45 feet. What this would require now in terms of phasing is we would establish the barge berth and TOTE operating areas in what we have today at the North Extension. We would then move TOTE into that position, and they'd have the required dimensions around their vessel. We would need to add another 650 feet to the current footprint of the North Extension then, and move Horizon in after that's complete. So that's the sequence of events to provide the necessary dimensions to accommodate not just TOTE, but barge operations and Horizon's operations. So that's the overall solution that we've dialed in on. Now, the activities that we still need to do is we've established a working group, and I mentioned this last time, where we meet regularly with the Corps of Engineers, Port, MARAD and their program manager, ICRC, their engineer of record, TOTE, Horizon, our users as needed, to make sure we're integrating a strategy together and solving all the problems. So the next step here is to send this phasing plan down to the Corps of Engineers Engineering Research and Development Center, who maintains the sedimentation models, physical models for the port project, have them run sedimentation analysis to quantify what we would expect now in the shadow of this development so as not to encroach on Horizon's berth. So that's the next step. We've got some give here. We can shorten some dimensions. This is our upper limit here. This would solve all the problems. But there's some give that we could make if we had to. So we've got to answer those questions from a sedimentation standpoint before we can really say this is a go. But this is the direction we're heading.
Thank you very much. David, you have a question?
Actually, I had a couple. Maybe when you talked to us before about this, there was need then for the additional dredging in that area, wasn't there?
Well,
and there was some concern from the Corps about timelines on that?
Well, there was, that was one alternative, is to do more dredging to create the buffer. When we looked at that, we recognized that what we'd probably end up doing there is undermining the dry barge berth trying to accomplish that. So it fell off the alternative list. It just didn't seem practical. So this solution doesn't require any additional dredging that the Corps of Engineers hasn't already programmed for. And that's a major cost benefit.
Okay, I'm sorry, I guess I'm confused. It still moves it that
South.
south a little bit,
Right, but the Corps was
just not as
already
far?
programmed to dredge to minus 35 in that area. So we're just shifting TOTE's vessel south enough to create a 400-foot buffer from what the Corps had already anticipated dredging.
If you recall, Debbie, one of the ideas discussed was dredging deeper, further north into the arm, so
Yeah.
you had swing area to bring the vessel around.
Now you don't have to.
Now you don't have to do that because you're actually docking further south by extending the dock further south.
And I just wondered, Tote, have any concerns? I'm seeing you back there in the corner.
Welcome, Mr. Lowry. Can you please speak up because there's folk on the phone.
George, did you get a copy of this?
No, but I'm familiar with it.
Yeah,
So-
we've talked.
Yeah, so, in speaking, how Todd adequately expressed the plan there, and we've met with Todd and the Port Group and the Corps of Engineers with this new phasing plan, and we are satisfied with that additional 300 to 400 feet that we have, which will be to our stern. The only the only reservation we have yet at this point, which the Corps said they would address, is what the siltation would be, still to our stern in that area, because where we are presently, that we had sedimentation problems there that were unanticipated. So the Corps has promised to take all this data and put it into their CRAE computers and create models and come back with a report allegedly showing what the sedimentation could be doing in the future. But it'll take, according to them, some months to do that yet. But I publicly thank the Corps of Engineers for coming up with this compromise plan, because it greatly improves this temporary position that we're in and alleviates a lot of our fears and concerns for safety in that area.
Can I just ask one more? And that is, when we heard from the Corps, I was really kind of shocked at their timelines for doing things and how long it took them to get a project into the work plan, 2 years out, so I think. Do we have any clue if they're going to be able to do this additional dredging assessment in a timely fashion?
Well, we're working with them, and we haven't identified any, I think, critical path issues in that regard. Julie, do you want to say anything? Julie Anderson from the Corps of
I
Engineers.
remember, I'm sorry.
This is the footprint that's already in our plan, and this area next to the dock, this has already been dredged. We're going to dredge next year, and then all the dredging to support the north area by the Corps will be done. What's drawn here doesn't require any increase or any changes in the plan that's under contract.
Oh, okay. I thought it was asking, you were asking for additional work. I misunderstood that.
Well, the work I think they're asking for is the modeling.
The modeling, yeah. Those
And
models
eventually-
exist, they need to be tweaked a bit, but that's a short-term issue.
And if that shows up, if that demonstrates some unexpected siltation pattern, then that might require a small change to what you're doing, but otherwise the plan works as written. All right, any more questions or comments on that matter? Moving right along. How'd the inspection go?
Well, I'm going to, it went well. I'm going to turn it over to ICRC. Marad is our lead agency, and Marad's contractor is ICRC in charge of the development. And so I think it's proper that ICRC
Great.
put a little, I think they're going to have a little slide.
Come on up, do we need an extra chair for you, Lynn?
And this is Linda Kuzian, ICRC's program manager.
And it might be easier, but you can stand or sit, whatever you want to do.
You want the lights down?
Yeah, that probably wouldn't hurt.
Hello, my name is Lynn Dukuzian with ICRC. I'm the program manager. ICRC has the contract to manage a program, and we are under contract to the Maritime Administration, and we was partnering with the Port of Anchorage on this project. And I'm going to briefly go over the preliminary inspection results. And I say preliminary because the full inspection has not been completed yet of the bulkhead or of the tail walls of this open cell sheet pile design. You have a handout that you'll be able to follow along if you wish, or make notes. It's the one, you have two handouts. One looks the same on the front cover, except it says preliminary sheet pile inspection findings in the title of the document.
And then would you prefer to have questions at the end or as we go?
Perhaps at the end, either way. If I'm not being clear, please let me know, and I will explain better.
We'll try and hold it to the end.
Okay. And when you ask me questions, I may defer to two other people with ICRC who are here in the audience today. We have Brett Flint, who is our chief engineer for ICRC, and Chuck Casper, design engineering manager and planning. Okay. This is a schematic on the screen that shows what typically is called the north end. It's a combination of the dry barge berth on the north side, the wet barge berth, and the north extension, which runs between outfall A, outfall B, and open cell sheet pile cell number 66. We typically refer to this section here between outfall A and outfall B as the north end of the north extension, which can be a little confusing. And then from outfall B to cell 66 is the south end of the north extension. And those differences are important because of dredging depth and things of that nature. What we have are a schematic of all the open cell sheet pile that either have been installed, or when you see these dashed lines, these are not in place yet. These are planned. And over here on the south side of outfall B, you also have some dashed lines which are planned as well, and installed are the thin black lines. Outfall A and outfall B are designators for storm drain outfall. This is where two of the, I believe, 6 newly designed storm drain outfalls will be eventually installed at the north extension or at the north end. So there's going to be a drain pipe here. So that's generally the schematic. As far as inspection results go, we've done 100% of the bulkhead inspections. That means the face of the installed open cell sheet pile have been inspected using underwater divers. And this is the face when we're talking about these sections here. This is land side on the top of the slide. This is water side to the bottom of the slide. Wet barge berth We've inspected cells 27 through 38, and you'll see two designations. If there is an X in front of the face, it means underwater divers have discovered at least one sheet that has an anomaly or appears to be damaged. It could be one, it could be more, but right now the X just designates you have seen damage at one sheet or more. The dark lines here, designated on the tail walls, show that damage was observed when those tail wall sheets were pulled. And in the tail wall, which is land side, the only way to observe damage is if you actually pull the sheet. All of these on the face have not necessarily been pulled. They've just been inspected by underwater divers. As we move south, here's outfall A, and these cells 1 through 9 in the north extension, or 1 through 8, have not been installed yet. 9 through 12 were actually removed. They were pulled this year, and we did observe damage on the face as well as some of the tail walls. And that damage was observed through pulling. As you move south, all of this was inspected. Did not observe any problems with these on the face sheets. And cells 32 and 31 here were pulled due to various construction reasons. And we did observe some damage in these locations designated by the bold lines. And then here we have outfall B. These have not been constructed yet. Moving further south from outfall B to the end of the constructed north extension, this is the extent of the sheet pile that has been installed. As you can see, we've got a few more dark lines on these cells here, 38, 39, and 40. Observed damage and 47, 50, and throughout the end here. Okay, that's what we have as far as preliminary inspections go. Our way forward is to complete the sheet pile inspection. Bulkhead is complete. We have some additional tail walls that, due to recommendations by our designer of record, which is P&D Engineers, and other indications in the field, that we believe we need to do additional inspections for the tail walls. So all the data is not in yet. And what you've been shown is preliminary. We're still going through the QA/QC process and tallying quite a bit of data together. We are in the process of an active construction project going on now, reinstalling some cells and doing winter stabilization. This is an annual event. We cannot do in-water work over the winter, so we must construct the project as far as we can, and then due to winter conditions, ice, stringent permit conditions, etc., we have to stabilize the site and then start up again next year. So that's in process. Our way forward is to continue to evaluate the significant amount of data that's already been collected to date and look for patterns and potential cause of the damage that we have observed. It's quite an effort. We are also evaluating the potential for collecting additional data, potentially testing geotechnical samples, maybe material analysis, and anything else that comes up per recommendations as far as helping tie down variables that may determine the cause of damage and then how to avoid that. And the ultimate goal over the next few months is to make sure we're developing procedures to ensure the successful installation of future sheet pile. That's it.
All right. Those are a few questions. So, Mike, you want to start?
Yeah, I don't have a lot of experience with a project this size. The amount of damage that you've seen, is this something you would expect, something unexpected? Is it normal? Is it above average?
I wouldn't be able to say that it's above average or normal. This is, there have been at least 180 of these installations throughout the nation, and P&D can discuss that at greater length, and also internationally. To my knowledge, I don't know if we've gone to the extent that we have on this project with the quality assurance program and making sure we go in and do the inspections and pull sheet pile to determine the damage. So I don't have a lot to compare to. I don't know if anybody else has some information to provide on that.
Go ahead if you want to.
Okay. This is David Pierce with P&D, president of the company.
Welcome, Mr. Pierce.
Good morning. We don't want damage. And so the other projects are constructed so that, and watched so that that doesn't happen. So I would say it's certainly occurred and it's not what we wanted.
But can't say for sure above average.
We are
Higher
doing it,
than normal.
I'm sorry. Difficult to say in that respect. We are implementing a stringent quality assurance program. Anytime there's questions or issues, or even if there aren't, we are going in planning to inspect either the bulkhead or pulling a certain percentage of sheet pile, just to make sure that the installation was the way we thought it was going to happen. So when you do that and you find something that doesn't conform to our specifications, that's when we take the corrective measures, and that's where we are now.
If I can paraphrase, you have perhaps a more robust QA/QC program than other projects may have had, and therefore you may be finding a higher number of errors than another project might.
That's very well paraphrased, very well said. This project is under a lot of scrutiny by a number of very interested people in the community and the federal agencies, and therefore we're making sure that what goes in, we have full confidence in.
Mr. Hall?
Oh,
sorry.
Chairman, I'm sorry. I have one more question, but it looked like somebody, you were about to weigh in on the first question?
Well, my basic question is, what is the damage? You know, there's damage and then there's damage. There's a little bit of damage, there's the whole sheet pile is broken. So what is the damage? And then kind of a follow-up, so what are the consequences of the damage?
That's
In
kind of
some
where I was
cases,
going.
damage is not significant, damage.
Right.
Some cases, it's catastrophic. So what is the damage? That's the basic question.
That's a very good question, and right now we are looking at all of the data in order to come up with a good summary of the damage. It varies, but in general, it may be a section of the interlocks which have separated. And we've inspected on the bulkhead, we've inspected down to the deepest depth at which the ultimate dredging will be completed by the Corps of Engineers in the harbor. So if we've seen damage, it has been in some cases a separation of the interlocks, which hasn't been described yet, but as the sheet pile go together, there's one's in place or partially in place, the other one is slid into it, so it's locking tight, and then it pulls into tension as the bulkhead is filled. We've had some of that. We have had a few curled sheets. Other damage is as minor as the bottom 5 feet looks a little bit mangled, or galvanization is a little bit scraped off or something of that nature. So it runs the whole gamut. I think a majority might be the interlocks, as we were discussing with P&D last night, separation of those for a certain distance.
And if I understand correctly, maybe I'm wrong, you've only inspected sort of what you can see. So you have not inspected below the dredge line or even below, I guess, the current mud line, if you will. So you don't know what's happening below that.
Right. At this point, we have dredged in front of the bulkhead to the deepest depth at which we will ultimately have, and then inspected above that. We have kept the tips of the installed sheet pile embedded, so at least 10 feet of embedment into the native soils, and that's for stability purposes. And if we need to go into it further, we can discuss that as far as some of the. I'm looking at P&D engineers for all their technical reasons. But
Okay. Mike, you have one more?
Thank you. Yeah, I apologize. I thought you were trying to weigh in on my question. I know you said in your way forward you want to try to find the culprit, why some of this damage is happening. And I'm wondering if you have any preliminary suspects, because it looked like, for example, on the wet barge berth, there was damage on almost every cell. But in the north end of the north extension, there was a good long stretch where you didn't find any damage at all. So I'm wondering if you have any preliminary suspects, any ideas what might be causing the damage?
It may be a number of reasons, in which case we are not comfortable at this point putting 1 and 3 together and coming up with 7. I think a lot of people have opinions, but they're not necessarily based upon fact and a rigorous evaluation of the data, and that's still to come. So we know that the structure can be built. So it could be a combination of a number of causes, not just a single cause. It could be a number of things. Hard driving, stiff clays, means and methods, or other things that have happened. And we'd rather not get into that yet until we can talk confidently about some real information.
Fair enough. Thank you, Mr. Chairman.
Thank you, Mr. Gutierrez. Mr. Hall.
The majority of my questions have been answered. The only one I have left, Lynn, is the damage that you found. What does it do to the overall integrity of the project?
At this point, when we have discovered damage, our process for the quality control and quality assurance is to repair the damage. And that may be remove the sheet pile and reinstall either that sheet pile or that section or that entire cell as necessary, depending on the requirements of the equipment and ability to do it correctly. The bulkhead will be constructed to specifications. That's the end goal. If we've identified damage, we will evaluate whether it's pertinent, whether it is causes any structural integrity problems, and if it does, then that gets repaired. Then typically it's getting replaced. So our intention is not to leave non-conforming sheet pile in place, and that's never been the intention, and we won't do that.
Ms. Sander?
That was kind of my question. And do we have a sense of how many have to be replaced yet, is my question. And then, just as a follow-up to that, the ones we've had to pull so far have caused our schedule to get goofed up and costs to escalate. So I'm wondering at what point the port will be able to respond, or ICRC will be able to respond about that part of it.
Let's say the financial part for item 4 on our agenda.
Okay, so do you have any sense of how many at this time, or is it premature?
I do not have a count yet. We're waiting for final reports from the underwater divers, making sure we don't report information that's incorrect. We've driven nearly 8,000 sheet pile. And at this point, I would probably go less than 50%, and I would assume considerably less than 50%. We haven't inspected it all, and we haven't evaluated it. So hopefully a small percentage, hopefully is not a good word to use, but I don't have a final answer for you that.
And
Yes.
then the question that was asked earlier about the portion that was below grade, is there a process for inspecting that? Is there a way you can check and see without excavation?
We have been discussing that. At this point, on the bulkhead, underwater portion, we have not dredged deeper than the ultimate harbor dredging, and making sure that we have at least 10-foot embedment of the tips, because the desire was to not impact the integrity of the sheet pile and of the cell. If there was no damage, leave it in place. And we have discussed with P&D engineers possible methodology to do a certain percentage of check, but there are a lot of logistic issues associated with that, and equipment access and safety issues associated with that. So that's still under discussion as to whether that is an appropriate thing to do. There has been opinions expressed that if it's embedded and there's no damage above that, then it probably has pretty good structural integrity as it is. I'm not the geotechnical engineer or the design engineer, so if we want to pursue that further, I can pass that to P&D engineers.
Well, I'm curious mainly because of the implications for cost and schedule. You said that you're not done with the testing. When do you think you'll be done with the testing?
At least by next spring. We have the stabilization that has to be done this year, so in the process of inspection, starting up next year. We have to wait for winter to wait for winter to go away. But you have to wait for the right conditions, soil conditions and ice, as well as permit conditions to be in place before you can even start the work again. So likely May before we can complete all of the inspection and start the completion of all the inspection and get a really firm handle on where we are. We're not just going to sit on the information we have now. We're working with it and identifying what else we need to obtain. And as we get holes filled, we'll be adding that to our ultimate procedures and recommendations for the way forward.
Then, if I heard you correctly, the only way you're able to inspect the tail walls is to actually pull that sheet pile and inspect it. Is that correct?
Yes.
You're just taking it back out of the ground and taking a look and then putting it back in.
Yes.
And approximately what percentage of tail wall sheet pile do you intend to pull to inspect as you're doing
Going
this?
forward, some we've already pulled due to reasons, for other reasons. We had planned to go in and pull them. Our intention this year was to do some inspection, was to remove some sheet pile already because we had determined it was non-conforming. So, and that's what we have done. And that's one of the reasons why you see the damaged sheet pile due to observations during pulling. Others we have pulled in the process to get to a point to start rebuilding those cells this year. Going forward, it's not going to be 100%, and perhaps I can turn that question over to recommendations by P&D. Jim Campbell, would you like to address that?
The question is approximately what percentage do you need to pull for appropriate inspection?
Well, what we did with the face is we started out with a small area of inspection. We found damage, so we inspected a larger area. We found damage there, so then we inspected the entire face. We expect to do the same thing with the tail walls. So someone noted that there's a large segment of this job in the center that we found no face damage on. So, for instance, in that area, we really want to inspect the tail walls and verify if we find no damage there, then we've got a part of the project we can stand on, and we want that. So our intent, and we're still discussing this with ICRC and planning it, but would be to start by inspecting. We're talking about inspecting every third tail wall, seeing what we find. If we found no damage there, that would give us assurance, and we'd probably stop there. If we found damage, then we would do more.
Okay, so I think what I'm hearing is, presuming everyone agrees, we'll inspect roughly 1/3 of all tail walls moving forward. And if we find damage, then we'll perhaps change that scale.
And we might modify that approach based upon other information we pull in and
Better and better,
patterns.
maybe you cut to a quarter.
Right, right. But we want to make sure ourselves and everybody else that the integrity is there and it meets the requirements of the spec.
Norman, you have another?
Yeah, just a quick question. I apologize for the latest, and hopefully it may have been covered, so I apologize if you have to repeat it. All right, I'm familiar with some projects in construction, and in some phases that you certainly, the owner, I guess you'd say, or the builder accepts the project as partially complete or whatever. Are we accepting each extension as they go along, or is it as a whole project, so that in case we have an undetected failure of a sheet or something like that, that later would have to be replaced? Well, I guess what I'm saying was who, and maybe that's a financial part question, but who would own that responsibility? At what point do we, I guess, the municipality, the port accepts? Is it extension by extension, or is it the whole project?
That's a question I can start off with tell you what I believe is that when we believe a certain phase has been constructed, accepted by ICRC and the Maritime Administration and the port, then it will be turned over. But you go through a rigorous process of making sure that it meets requirements, and also construction contractors are under at least a 1-year warranty for work that meets conformance as well. So even though we may accept it on a provisional basis, if there's any issues associated with it that are strictly due to the construction contractor, and we prove that out, then we work with them for any repairs as well. So the process is in a phased approach. And I know, Todd, if you have anything to add.
Well, I just want to add, the port has not accepted any of this work.
Thank you, Todd. All right, any further questions or comments on this matter before we move on?
If I may, just a two clarifications. First, the cells that had not yet been completed, those are scheduled for next year still?
Yes, and in some cases.
I wasn't clear at the end, you talked about all the cells have been completed, but there still are some that are for 2011.
I can't read these numbers. These little circles
Yes,
here
yeah.
in are cells submitted. Yes, some are being worked on this year, and others will be completed next year.
But they weren't part of your inspection plan because they weren't completed last year.
Correct.
And following up on what Jim said, when you talk about inspecting tail walls, are you pulling the entire, well, clarification, you talking about pulling the entire wall, or are you talking about pulling groups of sheets to look for damage in the sheets that are,
Most of these areas that we're talking about doing tail wall inspections have already been filled with soil.
Right.
So the tail walls have been engaged, they've been pulled into tension. So to get them out to inspect them, you could excavate them and inspect them that way. But the way we would want to probably inspect them is start from the free end, the furthest shoreward end of that, and then work forward from there. We can pull sheets, roughly say 60% of those lengths of those tail walls in there without affecting the structure at all right now. That additional length is required for high seismic events. So in the course of construction, we could pull those out and what's there is stable. Then to inspect further towards the face, then we have to excavate and pull. And so that's the
you're
sequence.
pulling them in pairs and then putting them right back?
We could do it that way.
Well, I'm not putting it in
What we've done to date, what's been done to date is we've pulled them completely out, but those were actually in areas that we already knew we had damage. We wanted to pull that work all the way out and then put it back in. So in this area, when we're going to be inspecting an area that we think might be good and we want to check it, we may do what you just said. We may, in fact, pull, select it, but I think that what we'll need to do is, I think we'll actually need to remove it and then put it back in.
And I would like to add that our decisions in many cases, we elect to go to the conservative route. We don't want to overdo it. We don't want to add more unnecessary costs, but if there is a question, then we go conservative. And we ensure ourselves that what we are ending up with is what we intended to drive and put in place.
Governor, final word before we move on?
I just want to mention that, to get back to your original question that started the conversation on the schedule. We feel, as the owner, that after listening and working with this problem, that the opportunity is there for us to stay on schedule to finish the north end, the entire north end, by the end of 2014, as we discussed a couple of months ago.
Just one more clarification.
Yeah.
So you're talking about pulling 1/3 of the tail sections for the inspection?
Inspecting.
Inspecting 1/3, so you're going to essentially install and take out and reinstall 1/3 of all of those tail walls.
And I don't know that it's necessarily the entire tail wall for 1/3. That whole inspection is still, the whole inspection approach is we're developing as we go along. We find the information and then we tailor the inspection in response to what we're seeing. And I think what Jim, you were talking about is every third tail wall inspecting that one, right? Is that?
Yeah, that's not a firm number. I mean, we might say, let's do 25% of them instead of every third. But
How many sheets have been, I missed that, 8,000, 6 or 8?
Close to like 7,700 is maybe close, or
Okay.
rough number is a little less than 8,000
Installed. Installed.
total, right.
All right. With that, let's move into our discussion of the technology of the day.
And then we have another handout, which will be the second slide presentation by P&D Engineers. As you see at the top of your sheet, it says Open Cell Sheet Pile Design. Be prepared to take notes on that one. And I would like to introduce David Pierce, who is president of P&D. And he's going to do part of the presentation, and Jim Campbell, who's senior engineer and vice president with P&D, will do the second half. And supported with any other questions or technical support is Chuck Henley, who's also vice president of P&D Engineers.
Well, welcome Mr. Pierce. Thank you for coming to join us. Welcome. I understand there's been an ownership change in the last couple of years here.
Well, there's been an owner that left.
Right.
The rest of the ownership.
Well, welcome. We appreciate your coming to talk to us about this.
Thank you. So the question of the agenda item was what seismic work had been done on the project. And we felt that in order to get you to that answer, that it was good that you understand how the open cell system works, how that question is actually answered in the project. So we're going to give you a little history, give you a little background, and make sure we're all talking the same lingo, pull you through a little basic 101 open cell design, show how that applies to the Port of Anchorage, and then Jim's going to come up and talk to you about the geotech overview, which is really the driver for the seismic question. So, a little history. OpenCell was first developed in the early 80s. Over the last 30 years, we have a little over 180 projects. You can see from the map that there's an awful lot in Anchorage, because that's, or in the Alaska area, because that's where we come from. We've expanded out into the lower 48 and international. In the lower 48, if you know your geography pretty good, those are long major river systems and many bulkheads of some length. With respect to how that compares to the port project, the port project, as you can see from the inspection schematic, there's several unique links there. At this point, I think you're about 1,900 lineal feet of what's been put in there. We have projects that have over 2,000 feet, 10 or 12 of them that are equal to or exceed that length. This is the tallest exposed wall height that we have at 75 feet, but it is not the highest stressed design that we have. We have many other designs that have higher stresses in them. And again, from the map in Alaska, you can see we have quite a few right around this area. Probably the most notable one that has every load scenario is the North Star dock that's right here in the port area. So the open cell system is comprised of flat sheets. I'm sure you've all seen this, but I'll just make sure you see it again. Flat sheet, this is a typical section about 1 inch. Those are driven in an arc configuration. They come to a Y location, which in this diagram is an extruded Y, which you have at the port. It can also be a welded Y. But it comes around an arc, it comes to a Y. We call this a tail wall. We call this an end cell. And at the end of the end cell, we have an anchor pile. In this diagram, you can see the anchor pile is constructed of another extrusion that's welded to just a flat sheet. During construction, it provides stability for the tail wall that's up in the air. After the fill is placed and the tail wall is filled, it's kind of like that bootstrap scenario. It's the last thing that's the aggravation you have to pull through the soil. The basic design concept is that there's a pie-shaped portion of the fill of the cell. That's called the active pressure wedge. It tends to fall down and push to the face based on whatever the soil properties are. And that pressure on the face goes into hoop stress, just like your breakfast this morning. It's pushing out your belly to your belt, runs around to the Ys. And at the Y location, the load in each face element and the tail wall is the same, so that load goes back to the tail wall. The tail wall is extended some distance and some depth to first resist the local stability loads, which is from that pi element. That's the first element. And the second one is you extend it far enough back to satisfy the global stability line here, which is that mass of soil when activated, wanting to slide along a slip plane. And we extend the tails far enough so that slip plane meets the factor safety that we're interested in. So Again, active pressure edge, push on the face, goes into hoop stress, goes to the Ys. The Ys transfer the load back into the tail walls. The tail walls are extended far enough for local stability and global stability. Any questions on that? Okay. So, here at Anchorage, I listed the key design elements that affect this design. And what I'd like to do is kind of go through Basic Design 101 and show you how this was affected our design. So this is a typical section that kind of relates to what you see here in this model of the typical tail walls going back in the soil, face sheets coming around to a Y point. So the first item we have listed was soil profile. And what that is the, nope, that's not going to do it. Soil profile would be the fill material that comes back in after the sheets are driven, and then the existing condition, based on what those soils are, say if they were coarse gravels or coarse sands, they have a higher skin friction against the tail walls, and therefore you would need a shorter tail wall in order to meet those local loads. If it was more rounded material and that had less friction, you're going to hear this a lot, the tail walls would need to be extended further back or deeper. With the consideration of the lower layers here, if this lower layer was actually came up right to the tip of the, or the toe of the face sheets, and it was even concrete or steel, the system would still be stable because the system strength comes to the fact that the tail walls are back in the soil. We're not counting on any of this material out here in the face to resist it. And if it were flat right along here, we would just have the tail walls extended far enough into the soil that as it was trying to be moved, we could just calculate the skin friction along the side here. It would be a stable system. What we've done here at the port is that we don't have concrete, we do have a dense layer, and we've extended the tail walls far enough so that a slip plane that we need to analyze for stability would be down in that denser material, which is a better resistance for the project. Next item, the bulkhead face is identified as the top of the sheet down to where we might dredge. And that's a key element because the higher the wall, obviously the more load that pie-shaped portion of soil would push on the face, loads up the front face. Live loads. The live loads affect us in two ways. The live load that's above that pie-shaped wedge adds additional load to it as it pushes out in the face, so we get a higher local stability question. And then the portion that's behind that pie shape affects the global stability aspect. It tries to push it along that slip plane when you analyze it, so you take that into account. The way you resist that is you extend the tail walls back further or deeper, depending on what the existing soils are. Seismic load. Seismic load basically is applied to this system by the massive material that's between the tail walls. It is activated during an earthquake event, and depending on how far the tail walls are extended back into the system, that massive soil tries to move with it. The larger the mass, generally along a flat face, becomes more stable. And you'll see in the typical section how that really comes up when we identified or account for the seismic criteria that we have. Actually the face height, the live loads, and the seismic event are really the major ones that drive the design of the system. And for this project, the live loads and the wall height stress the face sheets. So one piece like this gets stressed to about 4,000 to 6,000 pounds an inch. So as it's coming around the face, that's the maximum stress that it's working under. It has the capacity of over 22,000 pounds an inch. So it's only getting stressed in its normal operation to maybe a quarter to 30% of its allowable capacity. When we put the seismic portion in there, that actually only goes to about 10,000 to 12,000 pounds an inch. So we're just approaching half of its allowable capacity, which is well within any criteria for other structural systems. With respect to scour and ice, I listed them here. They're not huge issues to the design, but scour, all we're trying to do is extend the toe down far enough so that the protected scour wouldn't come down here and expose the toe, because if you did, material just washes out the bottom. The ice loads, we're not exposed to the connect arm ice sheets that are coming down. We're just getting backwash into our system. So as long as the soil pressure on the inside of the system exceeds the ice loads coming in the outside, we're good to go. Sheets are just the thing that holds the soil between that and the ice. It's really not a problem here. The last item is flexibility. So first, I've heard that you've had many questions about wall movement. Well, if the contractor, when he installs it, if he designs or he drives it right in the middle, and it's perfectly plumb, and they do each one of those each and every time, we got 3/8 inches of the movement in that interlock. So the first movement you see in this system, and every open cell system has movement, measured up to 18 inches in some places. But the first movement you see is that they've driven the sheets out there and they start putting the soil up on the outside or on the inside. Starts to push on the face, bellies out until those come tight. You have 17 sheets across the face. It's a fair amount of movement to start with. That load comes around to the Ys, starts pulling on the tails, and those tails start coming up. Our monitoring of that on other projects has shown that at about 45 degrees is how far those tails will begin to take up just under the first load. So, in this case, we're 75 feet. We've got maybe a foot and a half. We've got maybe 45 to 50 sheets taken up on that interlock. Movement number 2. Movement number 3 is that now you've put all of this material in between the tails, and we've stacked it up, and depending on what this lower material is, it could be compressible to that new weight. It doesn't only compress vertically, it sometimes tries to move down a slip plane or it tries to laterally move out. Method number 3, or movement number 3. You add those up, like I mentioned, we've seen movements in 18 inches. Monitoring of this wall, Jim?
Yeah, but we've seen movements on that same order on this wall.
Yeah. So yes, they do move, but it's planned for and it's happened on every project, and the flexibility of the system to account for it is what we planned on. Sands and gravels, that movement will be seen predominantly in the construction part, and when we preload it to stretch out the face. Clays tends to happen over 6 to 9 months. Certainly in the sequence of this construction, that would all be taken care of before we got to permanent structures. Typical schematic of the port project. You can see here up to this dark line that kind of matches the standard design that I just pulled you through. You can see that we've got the toe down into the material, 75-foot height. By driving the tail wall sheets, we've gotten the design slip planes down in this material that's good for us. And at that point, that was the original design concept that we had. And as we went through the scrutiny of the other people involved to review the design, we got higher seismic criteria we needed to meet. And extending the tail wall is how you take that. So this is a representation of how much additional tail wall sheet we needed to account for the seismic review of the project. So with that, I'll hand it over to Jim so he can pull you through what that reviews were and how we reacted to that. So Jim, I'll let you.
Maybe you should ask if there are any questions at this point.
Jim, before you start, yeah, I think there's a question. Ms. Osiander, you have a question for?
I have no engineering background, zip. And basically, I learn things just by listening to people. And so on some things, I feel like I've got a really good, and other things I've got zero knowledge.
That's why we're here.
One of the things that I had heard was the Bootlegger Cove strata was of some concern. It appears from your diagram there that you believe you've got your sheet pile down below the Bootlegger Cove strata.
So actually, Garth is he can give you the real technical. I'll try to give you the layman between Garth and myself.
That's a good idea. You're going to have to paraphrase it.
Bootlegger Cove material is a broad description of a series of many, I believe it's seven different types of Bootlegger Cove. Bootlegger Cove material that sloughed out during the '64 quake is not in this area. We actually have, I don't know if you call it the good part of Bootlegger Cove material, but this material here being tested, and Jim will show you the test that we've done, is actually good engineering material to get this down to and force those planes through it. So
It's actually good, the slides up here though, because there is, for instance, even on this slide, there's an indication on your soft mode. There was some material, some soft material near the surface that we did remove beneath the structure as part of the initial construction. So we've done a lot of investigation and testing of materials right at this site. And Dave's right, Bootlegger Cove is there's a lot of material that people refer to as being part of that. It's over a widespread area. And it's not the same material in every location, it varies.
7 different kinds of clay, is that what I'm hearing?
Well, someone is classified it as 7, someone else would classify it into 5 or 10. Every geotechnical engineer or geologist would probably have a slightly different take on it.
And you did enough borings deep enough in all the areas where there's piles driven to know that.
yes, we're very comfortable.
Linda, do you have a comment on that?
Well, Debbie I was going to say that we have taken geotechnical samples along the whole length of the bulkhead, just like she said. So they have actual data collected that supports what P&D is saying, and these are the stiff clays and they're not what other people are concerned with this, calling Bootlegger Cove. And also, may I just take 1 minute, and I apologize, I did not introduce Garth Howlett with P&D. He's the design lead. Jim Campbell is he's been taking the focus on the construction lead for P&D. So Garth is here as well for additional questions.
Or I may have you come over to my house later. Okay, go ahead, Mr. Campbell. Thank you very much.
Okay, so really, I just wanted to address fairly quickly here some of the background that's gone into the geotechnical design of this project. Probably old news to a lot of you, but there's been a tremendous amount of work done on this project. Just to start with, these are some of the players. This is called Project Start, but it's specific sort of to the geotechnical side of the project, having the foundation and soil conditions. So, Federal Maritime Administration, Federal Lead Agency, Municipality, Port of Anchorage are shown on here. ICRCs were for merit. What I want to focus on this slide is, to start with though, is that there are sort of 4, at least in my perspective, 4 key parties that have been involved in geotechnical design. Now your P&D has been responsible for preparing and designing this project. Terracon, which is a geotechnical firm, independent of P&D, has provide a third-party review. They've been very involved in the geotechnical aspects of the project. They review what we do. They do their own analyses. They have lots of comments that we've had to address many times throughout this project. Concerns. They do not just rubber stamp any design. So that's all under ICRC. But independent of them, then are two groups up here. One, the GIC, which has periodically throughout this project had presentations made to them, usually by Terracon, I think.
Both Terracon and P&D and ICRC.
Yeah.
That's a good question, just about that.
Yeah.
One of the concerns that I'd heard from some of the, or I'd read from some of the earlier GAC letters was, is Terracon truly an independent engineering company because there's some sort of economic tie there?
Well, both P&D and Terracon are contracted to ICRC.
But are P&D and Terracon, don't they have some economic ties at all?
No, we have no.
They do not? Oh, okay.
But if they want to give us revenue, we can have to.
If I can say something about that.
Sure.
The independent review that the GAC has mentioned all throughout this process is exactly that. All of these folks you see up there are part of the design construction team. That's the team. You wanted to get somebody from China or something that doesn't have anything to do with this, just take all those documents and just take all those documents and look at them and give them independent reviews.
That's this group here.
Verdict. And I will tell you, as being on the GAC, I have never seen anything from those folks.
From Erdic?
From any of those people, as an independent review. I mean, we just
read all the documents.
I certainly hope so. I've read everything you've sent.
Okay, let's.
But go
I
ahead.
appreciate the comment. We'll move on and then we'll come back to that.
Sure.
Yeah.
Okay.
Well, regarding, I would certainly say from our perspective at P&D, it's felt very independent. These people have tremendous professional integrity, and I know that no one's questioning that. They have questioned the heck out of what we've been doing at very high levels. So, and even, sub-consultants to Terracon, they have specialty expertise, and these people are experts in their field, and even if they're subcontracted to Terracon, they've raised many concerns and that have been addressed throughout the design process. But you're correct, so as far as contractually, we're all under ICRC, and separate from that is the Corps of Engineer, ERDIC, their Engineering Research Development Center. They have expertise there, they reviewed it and provided their review, I guess, to the Corps of Engineers through the permitting process. And then to the extent that you gentlemen have had a chance to review things, and you've made presentations and raised concerns or comments.
Jim, 1 second here.
The Corps of Engineers review was limited to making sure the wall would stand up for dredging concerns. I don't think it is a true assessment of all the geotech and all the seismic concerns of the wall.
This is Lynn. I would have to double check that, Julie, because I believe, I was not there for the ERDIC review, but I am told that there was significant geotechnical and seismic review, and that during that process, P&D needed to provide a lot of information that was even considered proprietary in their design calculations and modeling systems that were rigorously reviewed by ERDIC. And part of the permit we have with the Corps of Engineers is for each phase and design package that we have, ERDIC will continue to review. And when we make design changes or propose those design changes, those are provided to the Corps so that they may evaluate those, and if they have questions, then we will respond to those questions. So the next section to be constructed, we will be folding in any lessons learned or any design tweaks that are necessary into that package. And then ERDIC will have an opportunity, and in addition to Terracon, and I'm presuming presentations to the advisory council, we'll have an opportunity to review that and look at existing data and how the model, the regional models actually work and how they correlate to actual conditions. and then we'll continue on down that process. So it's a continual process of review.
And Lynn, are there redacted versions of those core reports available that, you know, so they don't have the proprietary information, but they do have the ERDIC conclusions or comments that are available?
I will need to check on that. I personally don't have them. It doesn't mean that they're not there. I know that the Corps Regulatory Department has received letters from the Corps Geotechnical that says the design is accepted. I do have a copy of that, and I do believe that's on the Corps webpage for the project. Other reports that may have been prepared by ERDIC, I'll have to double check and provide.
Maybe we could pursue that later,
Right.
and that things could be forwarded to them.
I think that's the gap.
That's a gap for me, that's
That
important.
you're concerned about, those units? Okay.
Yeah, I mean, they're our advisors, and I'd like them to advise us well.
Okay. I think run that one to death. So, Mr. Campbell, please continue.
Yeah,
No.
sorry. And certainly, it's you know, to get up to speed on this project, a new person, even a highly trained engineer, would spend months just reviewing all the work that's been done. It's not something that can just, sure, because so much work has been done on the project. But, so these are the players, I'll keep it short, we can talk about them more if you want to, but partial list of studies and documents and analyses that have been done on this project. And it's, for presentation purposes, I think it's easiest, rather than go through and talk about all of these, what I'd like to do is just group them into phases, what's happened on this project. Early on in the project in 2002, there were concepts, sort of concept type studies that were done for this project. It's a thing where you're going to go through and you're going to look and see if this makes sense, can we do this. Then we in 2003, 2004, and even actually the present day, but early on, we spent a lot of time and effort collecting site data, specific site data at the site. They did a lot of drilling, sampling, collected soil samples down to very deep, and then did a lot of laboratory testing on those samples. And the laboratory testing was done both locally at Dow and specialty expertise firms, remote, that could do MEP, which could do cyclic triaxial testing to get some higher, level data that we needed for seismic design. And then subsequent to that, a lot of design analysis. And the design analysis has consisted of, at the highest level, really what we've ended up doing is a lot of numerical modeling, computer models, three-dimensional and two-dimensional finite element models of this. P&D has done it. Terracon has also done it, and provided extensive reports on that, on those analyses. So, bringing us to the design phase, then once we've completed that, and then finally, as part of, once we construct this, then the next thing that we do is we're actually doing some monitoring. We install monitoring. When we build this structure, we're going to monitor settlement and movements and some other parameters as well, so we can confirm that the design is performing like we expected, and also monitor things like consolidation and that it's occurring at the rates we expected, so we can plan ahead.
Mr. Campbell, I'm not sure if you're the right person to answer the question, but do I recall that we saw less movement than expected in some situations?
That's correct.
That is correct. Okay.
Yeah, in some situations we have. It's been complicated. The monitoring's been complicated because of the construction. The construction that's happened to date has been drawn out over a longer period, and there've been other site issues going on. So. That hasn't always been the highest focus.
All right. Anything else?
Let's see, do I have anything?
You have one more slide, looks like.
Oh, yeah, this is an important one, actually. So really, it's good to have these slides. For the seismic design, I will say that this thing has evolved a lot. The very early concept in the same 2002 was certain configuration for this thing. Since then, we've collected a lot of site information, and we've done a lot of analysis, and we've had a lot of expertise come in and provide, inputs for what the seismic design criteria for this should be. The end result of it is that we've modified the design to accommodate that, in essence, made it to make it safer. So we've done that by making tail walls longer. We've done that by making sheets that extend deeper in the ground. We've done that by removing near surface soft material beneath the dock. We've done it by fiber compacting materials inside the dock, and probably other things as well. But the key is just that this design has changed a lot as we learn more. And
Associate has a question?
I do, one more. I haven't read this report, but I've been told that there was a recommendation under Mayor Begich to have some sections of this project be set up for an operating, let me get the words right here. Operating level earthquake, contingency level earthquake, and subsegments for maximum level earthquake. Has that happened, and what sections are for the maximum level earthquake?
that has happened. The operating level earthquake is an earthquake that has a recurrence frequency of on the order of like every 75 years. Contingency level earthquake is 475, and the maximum considered earthquake is
2,400 years.
I think it's the entire barge berth area. You'll have to
it's right here on the
right on
phasing.
right on your phasing map. You'll see
They're identified as essential facilities. The wet barge berth, the north extension area 1, and the south extension.
Are those for the maximum?
That's the MCE level.
Okay.
That's right.
And then, did you do the others for contingency and operating, or how does that work?
That's right. That's right, yes.
Todd, at some point, could you give us an update of which ones are contingency level, which ones are operating level?
Well, they're all at that level.
They're
The
all at-
whole facility meets that level.
But they're
These
three
areas that
levels.
are identified as essential meet the additional
Right.
MCE level.
Okay, so nothing's operating. Contingency is
Everything is
above higher.
operating, everything's contingency.
Contingency's not higher than operating?
It is.
Oh.
Yeah, the MCE level is the highest level.
Mr. Flint, you want to help us out here?
Brett Flint, Chief Engineer with ICRC. This really, the design is based on a performance criteria. The essential facilities are designed, and the maximum considered earthquake is similar to a 1964 Good Friday earthquake as far as force. And the idea is that those areas are designed so that if we had another Good Friday earthquake in Anchorage, the next day you could bring relief supplies into the Port of Anchorage over that dock. Those parts of the dock would survive that earthquake. The cranes on top of it may not, but you would be able to dock a ship at those areas and bring materials in. The rest of the dock would probably have some economically repairable damage. There would be damage there that could be repaired over time. The entire dock would be back up and running. At the contingency level earthquake, you have more of the dock that would survive that. You would have minor damage maybe in those non-essential facilities. The essential facilities would be basically untouched. And the operating level earthquake is similar to what we had a couple weeks ago. That's supposed to, nothing happens to the structure at all. It continues to function.
Thank you very much, Mr. Flood. Mr. Campbell, anything else?
I think that's all I have to say.
Any other questions? Are there any more questions for Mr. Campbell? I guess, just so I was clear on terminology, the live loads, that refers to activity on the dock surface.
Yeah, it would be like storage of containers, operating of a crane, a wheel-mounted crane or something like that.
Okay, that's what I thought. Did it trigger something to you, Ms. Osiander?
Yeah, that was actually another question I had. It appeared from the initial study of this whole project that there was somewhat limited loads within 200 feet of the dock face. And I got that from this thing. Port of Anchorage Expansion Study 202.
March 22.
Yeah, and at the very back here, it certifies under the design criteria dock live loads. And it said 200 pounds, I think PSF is pounds per square foot. Uniform live load within 200 feet of the bulkhead and 1,000 pounds per square foot beyond 200 feet. And I wanted to ask about that because I know sometimes they stock those containers down there.
Sure. You know, the first 200 feet of the dock face is really the operating area of the dock. It's not the area you'd normally store containers. I mean, this is the active area where you've got lots of vehicles coming and going. You've got forklifts that are moving things around. Typically, you wouldn't store, you know, containers in that area. That would happen behind that 200 feet from the face.
Okay, so that's still the specs that we're operating under.
Yes, ma'am.
Right. Okay. Anything else on that subject? Garth, you want to add something? No? Good. All right. I think we're ready to move on to our final item. My favorite part, the money. Governor, you want to take that one?
A couple more. Sure. The budget that we handed out the last meeting through 2014 still is in play. We're moving, as I said earlier, we plan to finish the north end by the end of 2014. Next year, it hasn't, we don't have, the ICRC does not have the bid ready to go on the street yet. It won't happen until the end of the year. But we'll start at the wet barge area and complete the wet barge area so the wet barge area, the dock can be used and the land behind it. And that's coupled with a Tiger grant program, Tiger number 2, and so that extends the rail line in to the north end, totally down to the barge docks. It moves the Cherry Hill Road over against the bank more, so there's more room in that area. Gets rid of the hump when you go from the old port to the new port. Underneath there was a pipeline that goes to Elmendorf, and that's been lowered now, so we'll go in and coupled with the moving the hill over the road over a little bit, we'll take care of that hump. So anyway, and the utilities are, ML&P just completed or in the process of completing the extension of power into the north end area now. All their duct work, it's all been paved over, nicely done. So what we don't have is the plan yet for some of the damage areas, and that'll be evolving every day, every week throughout the winter, and hopefully the ICRC will have a plan for that. We, as the owner, we want to work from north-south, because the dry barge dock is there, we're using that now, and we want the wet barge area done because there's a need for it, and we'll just continue to work our way south. At the same time, and you know, we get federal funds and we get some state funds and port profits and our letter of credit. We'll be able to finish the north end, and then our future plans are to start the south end on your phasing map. That's all the red on the right side. That's the south end. Primarily, the south end is for fuel and for cement ships and other cargo, but primarily that's the busy end during the week. The other busy end is the containers on the other end of the port. So we want to start the south end in 2012. Maybe order the steel in the winter of 2011, And it takes 5 years to do the red. So we'll be in there a long time. But in the meantime, we'll be finishing the north end, and we plan to start the south end in 2012. We are going to ask the state of Alaska to pony up additional funds early so that we can start to see the green light at the end of the tunnel. That all we'll have left then is the blue in the middle, which will be a little bit smaller than what your map shows here. And when we do that, then we can fill that in and then move our ships back, and then we'll call it good and we're done. But that's about 2021 that I've taken you to, 10 years from now. And that's about as fast as we could do it. But anyway, that's the plan, and we'll know sometime this winter, next spring, how that south comes together.
How much Tiger II money did you get, or do you have it yet?
Well, we're contemplating, it's about 13 million. The actual project that we're going to do next year is considerably more than that, but we're going to put 13 million of federal money, Tiger grant money in that.
And that's not on this one, right?
No, that won't be on that one.
Is it going to replace money, or is it just is it new money?
Just new money.
Okay. And about how much do we plan to ask the legislature for next year? Or is that secret stuff?
Well, I've talked to the governor about it, and I've done a lot of work on it. I'd kind of rather not get into that here. I'd rather have it announced first before we start to tear it apart.
We'll let the governor.
But there's a lot of work going on right now behind the scenes. We're going to build up enough support. We have a big program on, and with the University of Alaska, the logistics area on the port. We have a big program going on showing what the port does and why it does and where it's going. Like, 100 million pounds of freight bypass mail comes through the port every year. That bypass mail is in pallets. It goes out to distributors in the Anchorage area to get flown out to the bush. There's part of that 100 million pounds goes to Fairbanks on the trainer by trucks from the port, gets redistributed. And we've never talked about that, but there's a lot of things that the port does that people don't know. And we've known, but we've never put it all together. So we're putting this whole thing together so that the legislature will have cover when they vote for this project, and the governor. It's a campaign. So.
Is this the end of the question?
Well, the thing that's concerning me right now is these sheet piles that have the damage, and you probably didn't figure that in your cost estimate, that you're going to have to pull all these and maybe replace. But you won't know the full cost impact of that problem next spring. It sounds like, until the testing is done, right, Lynn?
Well, let me. I worry about the money. Let me just comment on that. Yeah, there is damage, and we've already spent the money. So we expect to, between our lead agency, MARAD, and ICRC, and the negotiations to be made whole for what we've lost.
You're not expecting this to cost any more money? I didn't understand that before.
We're not expecting to pay for damage.
That's right. I guess that's the way it is. We don't expect to pay for damage. In other words, we've already spent the money, and so we expect to be made whole.
Wow, okay.
All right. Is there anything else we need to go over today? Any more questions? Gentlemen?
No questions. Just a quick comment. Just ask the legislature, the governor, for a blank check. Just fill in the zeros with the project. Shoot for the moon.
Todd.
Mr. Flynn, I wanted to clarify one question because it was the one that Ms. Osiander asked about the load ratings at the facility. We expect the design to meet the requirements of the port. The existing port has a load rating. We expect this new facility to have a higher load rating. I think some of the forces that were listed in that report that were mentioned were not final build-out load ratings. So I just want to make it clear that if 200 PSF was the number that was in that report, and I've been around this with ICRC and P&D a couple times, I understand that to be the pre-finished condition. When the bulkhead has the cap beam on it and all the necessary appurtenances to service the needs of our customers, we will have a higher load rating than that.
There's a lot of different load combinations, as we've discussed about this before. You know, you could put a 300-ton crane out there, and it would be perfectly fine and stable. What the 200 PSF live load is that we've included is also incorporated into the seismic load combination. So it's very
complex.
It's very complicated.
Right. And that's why I didn't want that to just get to kind of go without being addressed.
You can tell deeper to hold your time. For example, where Horizon's cranes will be, there will be different piling beneath those rails to give you a higher PSF rating in that area, for example.
You know, I'm frank with you, I always am, and that is, I've had some conversations with people who are concerned and tell me that that load rating is too low. I don't have a clue if it is or not is, but if you've got something in a document that shows a higher load rating than that, at some point, it might be helpful for us to see it.
The significance is how the load combination is structured to meet the requirement. When you're designing for seismic, you don't normally include the entire live load that the facility could see at any given moment. It becomes too conservative. So you reduce live load to model seismic forces, okay? In the normal operating condition is not seismic. That is a very low probability event. That you would not see 1,000 PSF on the dock side, your highest seismic forces. I mean, there's design considerations that take all this into account. In the normal operating parameters of the port, we expect load ratings to meet those needs. So if we have 1,000 PSF at the wharf face to meet a short-term requirement for our customers, that's my expectation. Is this correct?
That's correct, and it's not a problem.
And that's the ultimate design case. In a seismic condition, it's different, and that's where there's confusion.
Okay. Well, this, I didn't think was a seismic report. It's just a draft of the design, I thought.
Go back to 2002, I think is what.
Yeah.
Yeah.
Well, that's why I said, if you've got something else, I'd be happy to see it.
We have something else.
Okay, super.
That was a good answer.
Okay.
If you'd be kind enough to get that to us.
Yes.
All right. Is there anything else we can cover today?
Just if that, I already forgot the acronym, of that independent agency that reviewed. ERDIX.
Yeah.
I've got more acronyms here.
Lynn's going to be working on that for us.
If we could forward that to these wonderful volunteers here, that would be super.
We will provide whatever is available. I'm not exactly sure what that is,
Thank you,
but
Lynn.
we'll go back and
Thank you
do this.
very, very much. And I did appreciate the letter that you emailed Patrick and he emailed me.
Oh, okay.
Thank you.
All right. Thank you very much, everybody, for coming. I appreciate the time this morning. Have a great day.